evening, folks. What's going on there? Earthmaster here, checking in on this Wednesday, February 3rd, 2021 is the date, 7:30 p.m. West Coast time here. We're the latest quake on the globe, a 2.5 earthquake striking out there in Northern California, or more or less looks like Central California area. You can see that 2.5 right there on the map. I'm going to jump right into the earthquake activity out here along the West Coast. And there it is. USGS map of 2.5 and above shows, well, you got the 2.5 there in Parkfield, California, right there on the creeping section, the creeper section of the San Andreas Fault here. You can see that, that red line indicating the major plate boundary of the North American and, of course, the Pacific plate to the west. 2.5 is not really abnormal to see on that fault system right there. In fact, they get those small 2-pointers and sometimes some 3s quite often in that region. Little 3.0 up here near Stanley, Idaho. Be quiet for the most part there in Idaho until we bring down the all magnitudes there. I can see some activity up around the Pacific Northwest and also some below 2.5 activity into Southern California as well. The only notable earthquake swarm down here is still right around the looks like the Yuha Desert area, right around the shear fault structure of the what's that fault? Yuha Wells Fault, and also the Ellensnor Fault System, the Laguna Salada, is that right? Section. And this Ellensnor Fault System is kind of an extensive fault that stretches all the way up here into the north. This one here is kind of the southern branch of it, I guess, if you will. But we're looking at about 32 earthquakes, 30 earthquakes or so within this region. This is kind of an interesting swarm. Not saying that California doesn't get swarming activity, but it's kind of out of the area where we're normally looking at potential swarming historically. So kind of keep an eye on this pretty closely. A 3.7 was the largest quake there in that little cluster, which has been going on for a couple days there. This is about 20 miles or so from the southern branch of the Brawley seismic zone and the Imperial fault zone here, which is an extensional zone of the San Andreas fault, which runs up here to the north all the way up through Northern California there and ends at the Mendocino Triple Point Junction there off of the coast of Eureka, right at the edge of the Cascadia Subduction Zone. I'll get to that here in just a second. Not a whole lot of movement in Nevada, folks. Check out the deadness, if you will, in Nevada. That's very unusual. Considering that we've seen pretty much all last year. I can't remember when that 6-pointer struck out there. Sometime in, I don't know, early 2020. And since then, we had seen continuous swarming, continuous aftershock activity in a linear fashion across the desert out here. This is a region where I took a trip down to and did a little bit of digging around. Didn't find much, except for a couple ghost towns and whatnot out there, but it was an interesting trip nonetheless. Only one earthquake in the 24-hour period, and that's kind of odd. That's very odd, and that is a 2.6. So either they're not being reported, or, it's hard to say. This is the all magnitudes. This is not just 2.5 and above, so a little on the strange side there for activity in Nevada. Let's shoot our way up here into the Pacific Northwest, where we're seeing a little bit of quaking going on around the volcano of Mount Rainier area. You can see a couple earthquakes there right around the summit and also to the west here. A couple small microquakes. Nothing really to write home about. We can check out the live seismic, or at least the seismic data over the last 24 hours of that region here in a minute. Also some activity here northeast, kind of northeast of the Seattle region. A couple small microquakes as well. Somewhat deep, not super deep, but somewhat. Compared to your normal 5-10 kilometer region there for typical earthquakes, 14 kilometers downstream for that 1.5. Let's go ahead and check out the tremor map, folks. The tremor map is looking pretty crazy. Let's go ahead and key that up there real quick. That's from today. Again, right? 2/3/2021, today's date. That looks very similar to yesterday's. 743 epicenters of tremor along with some magnitudes up in the upper ones, a couple twos in there as well, folks. Magnitude M energy 2.0. This is pretty much a long duration earthquake here in the Pacific Northwest in an area where, well, we're not expecting a tremor episode to happen. It's kind of stretching down towards the south and to the east in the region where we've seen prior slip. That 14-month intervals of some intense tremor west of Seattle there into the Puget Sound region and up into the southern part of Vancouver Island. So kind of watching this pretty closely. I do want to show you guys the week of data, past week of data here. Let's go ahead and search out real quick. And you can see quite a bit of activity up here, folks, in the Vancouver Island area. And this is definitely out of the ordinary when it comes to this type of tremor in this region. And, you know, some people could say, and I kind of thought maybe we're trying to just catch up, because a lot of times we see tremor areas to the south here in the northern California, and also a little bit of area up here to the north of this region. Not a whole lot has been seen in this area as compared to other regions along the Cascadia Subduction Zone. Thought maybe it's catching up. Maybe, you know, it's finally catching up, but we're also seeing not only the activity increase in the Vancouver Island area, but also along the entire length of the Cascadia Subduction Zone in sporadic areas. So that's something that's got me a little on guard here when it comes to watching the tremor along the Cascadia. The latest information from the folks there at the PSTN Pacific Northwest Seismic Network in regards to the tremor is as follows here. This is the data set out, or at least a statement put out on February 1st, so a couple days ago. The activity has not died down. If anything, it has increased. Let's see, this not cover everything, but I do want to add, okay, let's see, for the past week, something has been going on in the ETS area, so I better add to this blog now. Starting on about January 26, 2001, tremor started showing up in south central Vancouver Island and got stronger and longer over the next few days. This burst does not look to be a typical inner ETS tremor patch that is usually down dip east-northeast of the main ETS patches and lasts no more than a few days. Talking about that typical region there over every 14 months there in the area south of the Vancouver Island area. This latest batch seems to be a reactivation of the part of the standard ETS region. It seems to have started in the region of Vancouver Island that had some of the earliest tremor during the October 4th, November 16th ETS event, a burst going from October 15th to October 17th. Had expected that this latest burst might migrate northwest to fill an area that has not had significant tremor since a short burst back in January, February of 2020. That's kind of where I was saying that it's kind of playing catch up. You know, it's just kind of catching up with the rest of the areas that have seen a slow slip event along that area of the Cascadia Subduction Zone. However, up until today, it seems to be slowly moving southeast back into an area that had significant tremor a few months ago. That 14-month interval happened a few months ago. So it looks like it may be migrating back into that region where we just had that 14-month interval of ETS. But this afternoon, tremor started lighting up the northern part of this patch, and so maybe ultimately it will have some that continues onto the northwest. But we're still looking at activity to the southeast, as he had stated, or whoever this person is stated earlier in this little paragraph here. There is no question but that it seems that what used to be a fairly standard 14-month ETS that covered similar areas is breaking into different patches that cover the same general area but scattered out in time. It kind of makes sense. I don't think that this has any significance for hazard or changes in tectonics. That's just this person's opinion. We have been monitoring this sort of activity for less than 2 decades, a short period over the 300 plus years since the last major rupture on the Cascadia Subduction Zone. We really don't know what variations to expect over decade periods of time. So it's something to watch, folks, for certain. The Cascadia Subduction Zone, just doing a little recap of what it is here. Here is a cut-out overview of the plates. Let's go ahead and make this a little bit bigger so you guys can see. Just a little cutout. We're not going to go into high-depth detail, but you can see on this map here that you got Vancouver Island marked in the green area, right? Vancouver, BC. There is the island over there to the west. You got Seattle, Washington in the green. Portland, Oregon also in the green dot further south along the Cascades there. ETS zone. That is the area of where we're looking at slow slip events that happen on a regular basis there in that little shaded area. To me, it looks kind of grape. Little purplish area. Grape is just a color, right? Kind of used. Anyway, that's the region of the slow slip event tremor. And the Juan de Fuca plate, you can kind of look at the bottom. You got the Pacific plate. The mantle upwelling is kind of like a separation of those two plates right there. While you got the Juan de Fuca plate moving off to the east and down underneath the North American plate there. It ultimately gets melted, right? You can see those little red melted drops over to the right side of the screen, bottom right. For some reason, my arrow is not being picked up here on this map. But that's kind of where the the plate gets melted and gets demolished and ultimately forms the volcanoes there in the Cascades and whatnot, stretching into Oregon, Washington, parts of Northern California. So the area that is locked is kind of where that black line is that says Cascadia Subduction Zone with the green with the arrows. Kind of looks like a cold front system that you would see on any weather map. That's kind of where the locked area is, if you will, off the coast. So this tremor, this high amount of tremor that we've been seeing over the past few months and including the past week is kind of what's got me a little bit worried, because ultimately the amount of tremor that we're seeing is ultimately leading up to and increasing the back build pressure upstream in the locked area of the Cascadia Subduction Zone, if that makes sense there. You just can't have movement, this plate being subducted, the Juan de Fuca plate being subducted underneath the North American plate where that slow slip event is going on, and not have an effect, cause and effect, right? The effect is ultimately the pressure that's being generated backstream, back up towards the surface, back towards this locked area of the Cascadia Subduction Zone. So that's kind of what's got me a little bit on the concern side with this whole event. I want to show you guys here. Let's run over here real quick again. I'm not going to make this terribly long, but looking at the scale, let's see if you guys can see what I'm seeing, hopefully. Yep. Looking at this scale up here, just goes back over the past 10 years or so to 2010. These spikes up here are counts of tremor that happen on any month, any given month out there. And you can see, for example, that's 441 episodic tremors on the the 20th of 9/20/2012, 441, and so on. You get that. The higher the graph view is, the more the numbers. Check out towards the end of 2020. We've seen a huge spike, a couple months of tremor that was well above any other years past. And now we're starting off 2021 with an incredible spike as well. And as I just mentioned, over the last week, we're looking at 3,791 epicenters, mostly confined to the Vancouver Island area, the southern section, and extending back into that region where we had already seen that 14-month tremor episode there, west of Seattle, northwest of Seattle, in that region. It comes on like clockwork, folks, when we see that that little 14-month interval. It happens right here within this region, and it goes on for a few days, and then it disappears, and then it comes back another 14 months later. But what we're seeing here, it's only been a few months. It's only been since about October since that 14-month interval. It has not been 14 months. Trust me. Time does not go by that quickly, thank God. But it's something to watch, folks, because this is definitely out of the ordinary. It's not something that we're used to. For the past, let's go ahead and check out the past month of activity here. I hope I'm not getting a cold. I'm starting to get a little stuffed up here. 7,720 episodes. Okay, list not generated for more than 5,000 epicenters. So Definitely a lot more on this map than what it's showing. This is the region here where we're looking at. Of course, the areas to the south have seen some movement. There's that blind area, that little region in central Oregon that just doesn't see a whole lot. While the rest of the plate bends and subducts underneath the North American plate, we're ultimately straining not only the back section here in the locked area of the Cascadia Subduction Zone, but more so in this central region off of the coast of Oregon there. I believe it's Florence, Oregon, right off the coast there. I believe where the potential next rupture could be when it comes to a megaquake. And that's not good for those folks there, trust me. So it's something to watch, folks. You know, who's to say what's going to happen? I was waiting for this new map to come out in hopes that something had changed, but it hasn't. It's still roughly about the same. There is a little bit of, you can see a little bit of northwest migration there, that kind of like what that guy was talking about there in that article, but not much. Most of it's confined there to the southern part of Vancouver Island area, and then sporadic activity pretty much along the length of the Cascadia Subduction Zone. But once again, there is areas where we're not seeing a whole lot over the past couple days, but to see sporadic activity on a lengthy chart here, I'm talking about from the southern part of the Cascadia up to the north, is a little bit on the concerning side. Man, I'm starting to get stuffed up, not for sure why. So, be on guard, folks, is all I'm going to say. We haven't seen any type of surface quaking far as actually relieving pressure either. A lot of times we can see some deep movement. Let's see, this is the earthquake activity over the past, well, couple hundred years, 5.9 and above. There are times when we're seeing some deep movement or some deep earthquake activity inland that can take place down dip. You know, not too far down, but down dip around the slow slip area. That's kind of what I'm waiting on for potentially Central Oregon to maybe see a larger earthquake finally release some of that tension that's been built up downstream here, where the slow slip event hasn't really covered compared to the rest of the Cascadia Subduction Zone. But this is just the activity over the past couple hundred years. Doesn't show the mega quake here, but it does show where 5.9 earthquakes and above can happen along the Cascadia and parts of the Gorda Escarpment, the Gorda Plate, and the Juan de Fuca area, and of course inland. I believe Klamath Falls had a pretty deep earthquake there. Let's see, that's a Klamath Falls one, but I think that only shows 8 kilometers. I know one of these was a pretty deep one. But either way, we can definitely get some surface tension up here as well that can release energy. But it's this back buildup pressure, folks, that's kind of got me a little bit worried there. What's this? Let's see here. There was a couple images I wanted to show here in this video. Maybe that's not it. There's just another overview of the locked area, right? Kind of stretches all the way up here in the Vancouver Island. The stuck or locked part of the interface between the North American and the subducting plates, the fault that breaks in great earthquakes. That's this area just off the coast here, folks. Stretches down. There's that cold front looking system. Well, I guess this would be a warm front on a weather map, the red one. But it stretches from northern Cal all the way up into Vancouver Island. This one does not show the slow slip area where that takes place, but it's inland, but under the continent, down dip, downstream where the Juan de Fuca plate, the Gorda plate, subduct underneath the North American plate. The spreading ridges where plates separate and injected magma forms new oceanic crust. That's this area right here, kind of separation, and you get this slow movement of magma creating the new ocean floor. Vertical faults oriented so plates move parallel to one another. That's this linear fashion right here. That's this area up here around the Explorer plate. Not a whole lot of people hear about that, but that is a little bitty plate up here. So that's just another map. Here's another layout of that Not super good. Just kind of gives you an overview of the subducting region, and of course it gets melted down below, and it forms what, volcanoes at the surface, right? Deep earthquakes, magnitude 6.8. What is that? Nisqually earthquake in 2001 was a deep quake. This type of, let me see here. .8. There it is. I believe that's it. Look at the depth on that. 6.7, Seattle, Tacoma, Washington. This is down dip, downstream. This is a Cascadia earthquake here. Wow, a deep one, 59 kilometers down down below the surface there. This is what I was talking about, how we can see these deeper earthquakes in a large-scale movement because things get stuck. Even though we got slow slip event going on down below the Cascadia, you know, underneath the North American plate, things do get stuck, and that's kind of what I'm worried about here for potentially the Central Oregon area. You could potentially see an inland quake, but deep, way deep, down below, potentially right around the slow slip event area, 20, 30, in this case, 60 kilometers below. It's very possible. There's another one that's 6.8 right there, 70 kilometers. 51 kilometers. These are all deep earthquakes that struck back there. And those are some pretty large quakes. They don't do a lot of damage at the surface, but they're felt pretty far out. But, even though they're deep, it's still felt at a wide area. And not saying that there isn't any destruction or any type of damage at the surface. It does happen. Hopefully I didn't, it looks like I left my earthquake 3D bell on. Hopefully that thing didn't go off while I was chatting here on the video. But either way, these quakes can happen. It's been a while since we've seen a deep earthquake. Looks like 2001 was the last one. What's the interval on that? 49, 65. So it's possible we could see some further deep movement on the larger scale, and it's there. So not only do we have to worry about a mega quake, a 9.0 or greater, on the Cascadia megathrust area, we also have to worry about potentially inland deep earthquakes as well, especially with what's going on with the tremor recently over the past week. So it's something to watch and it's something to worry about, but there's really nothing we can do but just be prepared is what you can do. Be prepared. There's some shallow or crustal quakes that they talk about. This is a pretty cool looking map here. Or a website. It gives you quite a bit of information. The two magnitude 6.0 earthquakes that struck Klamath Falls are examples of this type of quake. The shallow or crustal quakes, right? Occur within the North American plate along fractures created as a result of the collision process and jolting of the blocks of continental crust. Start bending that continent, it's going to create quakes, right? Here's a little overview, and this is what concerns me. If I lived on the Oregon coast, Washington coast, Northern California coast, is the tsunami, the potential tsunami devastation. Okay, so this is a cutout. We're looking at cutouts of the top up here is some grass and recent dirt, and maybe some mud in there. You got some tidal mud, right? Check out the sand deposited by the 1700 tsunami that was produced by the Cascadia Subduction Zone that laid down a whole bunch of sand inland. So it's very scary to be living along the coast these days, especially when the potential strain is building up and building up. It's kind of scary. This kind of shows you exactly how a tsunami forms and whatnot. There's the potential earthquake shake map for an expanded scenario of a 9.0 earthquake, and potentially we could get something bigger than that, folks, along that Cascadia but this is the shake map for the Pacific Northwest. Man, I tell you what, I live here in Northern California. I'm looking at some very strong shaking. If this thing rocks anytime in my lifetime, which I think it will. If you want to check this out, folks, there's so much information on this webpage. I don't want to go through it all. I'm going to copy and I'm going to paste it onto the description of this video in the description part. So if you want to check that out, please. It'll take you an hour maybe to read, maybe less, but I would suggest reading every part of it. It's pretty cool, and it's also very informative, for the folks that do live in the Pacific Northwest. So I will do that. It will be in the it will be in there. What else we got here? Worldwide earthquakes, folks. Let me check, see what's going on out here. There's not a whole lot, just some sporadic activity. There's that 6.7 from last night. Downgraded, right? Originally it was 6.6 or 6.7, got upgraded to 6.9. And then after I made the video, got downgraded to 6.7. Couple fives up through the western part of the Pacific Ring of Fire. Nothing really to write home about anywhere else. Africa region, seen a little earthquake over here, 5.0. But other than that, things are pretty quiet globally for the most part. I did make a little bit of difference or a little bit of adjustment here on the earthquake 3D globe. Someone mentioned to add potentially the plate boundaries onto the map. That's these red lines here indicating the major plate boundary. In this case, the Pacific Ring of Fire that stretches all the way around the Pacific Plate. Huge plate. And it's pretty cool to watch, pretty cool to look at, especially when you see earthquakes striking within that region. So we'll go ahead and keep that up here for the extended future. Unless, it's not the most beautiful globe. I kind of made the adjustment a little bit to make the water a little bit bluer. Looks a little bit different compared to the other one I was using, but still, it shows you the plate boundaries and where the potential for some larger quakes and quite often just numerous quakes could take place. So stay safe, folks. Be on guard. We're still watching that Cascadia. I'm just really surprised we haven't seen any surface quaking going on the larger side of things. All right, folks, have a good night. I'm going to go clear out my nose. I'm not for sure what happened. We'll chat to you guys a little bit later. Stay safe out there.